my name is Basharat Hafiz Siddiqui, and today I'm discussing you the surge protection device. So let's get started. What is the surge protection device? If we are discussing about the protection, there's a lot of protection electrical system related to relays, related to circuit breakers, and if we are specifically talk to a circuit breaker, then it will provide the short circuit protection and overcurrent protection. But what about the voltages? What about the transient that is coming to the voltages? Harmonics and transient. For that, we are specifically strict to SPD, which is surge protection device. Now, what SPD does, SPD do whatever the transient come from your grid or due to your system, it will safely bypass it to the earth. And what is the cause of the transient surges? There are many much, but here I am mentioning a few. Like if I'm tagging to a one is the equipment failure. If your equipment is failed, and the surges will come into your system. If your system has a lot of static loads, due to switching off the static loads, the surges will come. The operational shutdowns will also create the surges. And the damaged equipment of damaged communication equipment, or in the case of any event or sabotage like fire or any worst case scenario, the surges will come into your system. Now, what is SPD? If we are deeply discuss what is an SPD, the SPD is simply a high impedance device. It will act very high impedance device unless and until the selected operating voltages will reach, and the SPD will go from high impedance to low impedance device. What are the factors that will reach to a value so the SPD become active and provide a low impedance path from the transient uh, phases to the neutral or from to the earth, right? There are many factors we have to discuss one by one in this webinar. Like before that, we have considered the component of SPD. The SPD has two components. What is the voltage limiting, and other one is the voltage switching component. So what voltage limiting component does? Voltage limiting component just clamps the transient voltages which is above the maximum operating voltages. It will clamp it out. While the switching components, what is the voltage switching component? It will act like your SPD is a very high impedance device. Once it will get, it sense the transient, it will goes into switching phase, and it will act as a low impedance device. And once it becomes a low impedance device, it will provide a low impedance path for the voltages that is exceeding the limit, and thus providing a safe passage to the earth. Now, what are the factors that you have to be considered while you are selecting your SPD? Like the ones, our important factors UC, or sometimes it's called MCVOs. What does it mean? It's a maximum continuous operating voltages. Either it's a AC or a DC, depend upon the selection of your SPD. But mostly SPD will today's now come with a DC and AC both protection levels, voltage levels. So what does it mean? The UC here in this case, if you are looking to the this picture, is 385 volt, right? What does it mean? It means that SPD will act as a high impedance device unless the voltage, transient voltage, reaches 386 volt. So the SPD become into the voltage switching device, and it will become a low impedance path, and it will suppress all the transients to the earth. Now, a standard of IC 60634-4-4 states the UC calculations in their table. What does it mean? We have different type of earthing system all over the world, but for the UK, the subcontinent and the subcontinent usually uses the TT earthing system. What is the TT earthing system? I will explain in other videos related to the earthing system, but for here we have to only consider the TT system. The TT system stated from line conductor and the neutral conductor, it will be 1.1 into the phase voltage divided by the root 3. So if we calculate TT for the system is 254 volt, right, here for our system. But now for the sake of learning, here the SPD selected is 385 volt. So we are going with it. Hope you will understand what is UC. The other important factor is the factor IN. So what is the IN? So IN is the nominal discharge current. What does nominal discharge current means? It's a, if here it's mentioned that IN is 20 kiloamps. 20 kiloamps. What does it mean? It means it's a peak value of current having a waveform of 8 oblique 20 mu second. Means this at this amplitude, the current waveform of 8 oblique 20 mu second will come, and the SPD should suppress this discharge current at least 20 times during its life cycle. It's a nominal discharge current. So where we get the IN on it on a SPD, and where we get the IMP, these are the two important factors. Now here we are using SPD type 2. Why SPD type 2? Because if we are looking towards this paragraph, here it is mentioned that the IN is only used to classify the SPD type 2. For SPD type 1, we have the impulse currents. So what is the impulse current? The impulse current is the current, if it is mentioned, is 40 kiloamps. So what does it mean? That at this 40 kiloamp amplitude, the current waveform of 10 oblique 350 US, the SPD should discharge it 20 times during its life cycle. Now, what is the Imax? Here it is mentions 40 kiloamps. So Imax is the maximum current that a SPD can dissipate at least one time during its life cycle. So for as we discussed earlier, for type 1 and type 2, there are different waveforms for type 1 and type 2. For type 1 SPD, the maximum waveform is 10 oblique 350, and for the type 2, the maximum waveform is 8 oblique 20. Since we are using type 2, so it means the 40 kiloamps amplitude of current, 8, the waveform of 8 oblique 20, it will capable of discharge it at least one time during its life cycle. The other important factor here is UP. What is UP? UP is the maximum voltage that an SPD can handle. Simply, if there is mention is 2 kilovolt, less than or equals to 2 kilovolt, what does it mean? That the SPD can handle this voltage. Okay, they handle this voltage is if it come to your system, right? So UP should be selected as per the equipment that is installed at your facility, right? The IC standard 60 664-1 state that for a 230/400 system, 1.5 kilovolt of UP is selected for the electronics devices like computer, TVs, PCB boards, and etc. For type 2, you have to select 250 kilovolt UP. What does it mean for the household thing? What does it mean? It will be a toaster, a drill machine, a pump, or a washing machine, right? For type 3, the UP should be 4 kilovolt, and it is used for the distribution boards, for example. Oh, now we have to check the mode of protection that SPDs to be installed in different hierarchies in order to provide the protection. For Y and D connection, there are different modes that is used to protect either phases or neutral. So for differential mode is also used, is only used between line to neutral in Y, and for delta from line to line. And for the common mode is only used between neutral to potential conductor, it's earthen conductor, and for the delta connection is used between the line and the potential conductor, because in delta there is non-neutral. So it's also depend upon the earthing system that you are using. For the GT earthing system, I focus to use differential mode of protection in the system. We will discuss this in detail in upcoming videos, and I will provide the complete calculation with the calculation sheet. I will discuss you how to calculate UC, how to calculate UV, and the other factors which is very important, like transient hour voltages, temporary transient hour voltages, TOV1, TOV2, and where you have to select the SPD type 1, type 2, and type 3. I hope this session will enhance your knowledge, and it will help you to understand what are the parameters of an SPD. Thank you.